Hi y'all, this is Mrs. D and I'm back with another video. Today we're going to talk about adding and subtracting inequalities. So let's go ahead and get started. So when we're adding and subtracting inequalities, we're talking about one-step inequalities that can be solved using the addition and subtraction properties of inequalities. Now let's go ahead and review these inequality symbols and their meanings. So the symbols are on the left side. We have our less than, greater than, less than or equal to, greater than or equal to, and those are actually the meanings of them. Now just to remember, the less than symbol, if you make an L with your left hand, that's going to be pointing in that direction. So that's just kind of an easy way to remember that your L with your left hand is for the less than sign. They start with L. The greater than goes the other direction, and then less than or equal to, greater than or equal to include the equal sign or part of the equal sign below the symbol. So if the number with the variable is subtracting, we're going to add that number to both sides of the inequality. This is the same process when we were solving one-step equations, but this time instead of an equal sign, we have an inequality sign. So it's the same process, but really the meaning of this is that we could have multiple answers. It's not necessarily going to be one number that makes our statement true. So let's see what this looks like. So if I have the inequality x minus 3 is less than 5, then I'm going to first look at the same side where my variable is located. So in this case, the x is on the left side of the inequality. And I'll go over in a minute that it is helpful if you have your variable on the left side. So if it's not on the left side, I'll show you how to change that here in just a minute. It says in our step here that if the number with the variable is subtracting, we want to add that number to both sides of our inequality. So instead of subtracting 3, I want to add 3 to both sides. Now, same process as a one-step equation. I want to keep my equation, or in this case inequality, balanced. So whatever I do to one side, I have to do to the other. Now the reason we're going to add 3 is because we want this minus 3 and plus 3 to equal 0 and cancel each other out. So now x plus 0 is just x. My inequality is still less than. And if I solve the other side, 5 plus 3 equals 8. So that means that my inequality is x is less than 8. Now let me show you how to graph this, and then we'll talk about what this inequality actually means. So when I'm looking at this, I'm going to find my 8 on my line graph because that's where the number that I'm given in my answer is. And because it's a less than symbol, that means that it's actually not going to equal 8. So I'm going to put an open circle at the 8, and then I'm going to draw my line everything less than, and then I'm going to put an arrow on the end because it is going to continue forever. That means that if I plug in any of these numbers that are less than 8, it's going to make my original inequality true. So let's try it out. If I were to take the number 4, if I plug that in here, 4 minus 3 equals 1. And I do know that 1 is in fact less than 5. So that does make for a true statement, which does mean that I have shaded in the correct direction. If I would have plugged in a 10, 10 minus 3 is 7, and 7 is not less than 5. So I would know that 10 is not a valid option. Therefore, I have drawn my arrow in the correct direction. Let's try another one. Now, this one you see, my x is on the right side of the inequality. So let's first go through the process of solving this one. And so I'm going to look on the side of my variable. I'm subtracting 1. So the opposite of that, or what I'm going to do, is add 1. And whatever I do to one side, I have to do to the other side. So I'm going to add 1 to both sides. So that means that my left side is 4, and my right side is now just x. But I want my x to be written on the left side of the inequality. So if I'm going to move my x to the other side, I also have to flip my inequality, which means instead of a less than or equal to, it's going to be a greater than or equal to, and 4. So x is greater than or equal to 4 is my actual solution. Now if I graph this, I'm going to find 4 on my line graph, and I found it here, so I'm going to put a closed circle this time. So if it is not equal to, if you notice on this first one we did, x is less than 8, I had an open circle at 8. The next one says greater than or equal to, so I had a closed circle at 4. Now I'm going to shade everything greater than and draw my line. So the helpful thing in having your variable on the left side of your inequality means that your inequality is actually going to be pointing in the direction that you're going to shade or fill in on your line graph. So now if I take any number 4 or greater, it's going to make my statement true. So let's try it out. Let's take the number 6. So if I said 6 minus 1, well, 6 minus 1 is 5, and 5 is actually greater than or equal to 3. So that does check out, so that means I have shaded in the correct direction. If I would have rewritten my inequality here, and I put my x on the left side and forgot to flip my inequality sign, then my answer would have been untrue because I would have drawn my arrow going in the other direction. So just keep in mind that you can always take one of your numbers and plug it back into the original equation or inequality to see if it is actually a true statement. And if it's not, you probably made a mistake with the direction that your sign is facing. Now in this situation, what would happen if the number with the variable is adding? And in that case, we would subtract that number to both sides of the inequality. So let's go ahead and do a practice one here. So now I have x plus 3, and instead of adding 3, I'm going to subtract 3. Whatever I do to one side, I have to do to the other. And remember, our goal is to get the x over on the left side by itself. So I need this number to equal 0. And plus 3 minus 3 does equal 0 because those are opposites. So I'm left with x on the left side. My inequality is less than, and 10 minus 3 is 7. So now we're going to graph our solution. So I'm going to find my 7 on my graph. I'm going to put an open circle because it's just a less than sign, and then I'm going to shade everything that is less than 7. So I can use any of these numbers. Let's go with 1. I'm going to plug in a 1 here, and 1 plus 3 is 4. 4 is less than 10, so I do know that that is a correct statement. So next we have plus 8 on the side of our x. So instead of plus 8, I'm going to subtract 8 from both sides. So that means that plus 8 minus 8 equals 0. I have x left. I'm going to write my greater than or equal to sign, and then 5 minus 8. So I'm subtracting more than I have, which means the difference is the number 3. And because I'm subtracting a bigger number, my answer is going to be a negative. So now I'm going to find my negative 3 on my line graph. I'm going to do a shaded in circle, and then I'm going to draw my line greater than, which is to the right. So I did have a shaded circle because it is greater than or equal to. Now, if I plug in any number that is greater than or equal to negative 3, I'm going to come out with a true statement. So let's try it. If I try the number 0, 0 plus 8 is 8, and 8 is greater than or equal to 5. So that is a true statement. So let's go ahead and try a couple of practice problems. So now we have y minus 5 is greater than negative 7. So on the side of my variable, I have a minus 5, which means I'm going to do the opposite, and I'm going to add 5. Whatever I do to one side, I have to do to the other. So my minus 5 plus 5 is going to cancel. So y is now greater than negative 7 plus 5. So once again, my negative number is the greater number. So the difference between 7 and 5 is 2. And my negative is with the bigger number. So I'm going to end up with a negative 2. So y is greater than negative 2. Now let's go ahead and fill this out on our line graph. So I'm going to find negative 2. I'm going to draw an open circle at negative 2. And then I'm going to shade greater than, which is to the right. Again, I can plug in any number greater than negative 2 and see if it's going to be correct. So let's try 1. If I have 1 minus 5, I'm going to end up with a negative 4. And negative 4 is here. Is negative 4 greater than negative 7? And the answer is yes, because it is closer to 0 and farther to the right on my number line. Now let's talk about a real-world situation where we're dealing with inequalities. Joel has at least $10 more than his sister. If his sister has $45, how much does Joel have? So that means that Joel has $10 more than his sister. So his amount minus $10 is greater than the amount his sister has. So now I need to solve by looking at the side with the variable. In this case, I have minus 10, so I'm going to add 10 to both sides. Well, 10 minus 10 is 0, so that means Joel has greater than or equal to 45 plus 10, which is 55. So Joel has $55 or more. So let's talk about our steps here one more time. And first, we're using one-step inequalities that can be solved using the addition and subtraction properties of inequalities. If the number with the variable is subtracting, we're going to add that number to both sides of our inequality. If the number with the variable is adding, we will subtract that number to both sides of the inequality. And we always want to add or subtract the same number in order to isolate our variable so that we can solve for the inequality. If you still need more help with inequalities when you're adding and subtracting, you can watch this video a couple of times and be ready to ask some specific questions. This is Mrs. D signing off with Add and Subtract Inequalities. Have a great day.